Welcome to the Crazy Hat Chemist. So here we go. Video number 6 on scientific measurements, rules of significant figures. Bam! Say, rules of significant figures. So the first rule here is non-zero integers count as significant figures. Examples of non-zero integers are 1, 2, 3, 4, 5, 6, 7, 8, and a 9, or any combination of those numbers. Okay? All right, that's the first rule. Non-zero integers always count. Next one is rules of zeros. There's actually 3 rules of zero, so here's the first rule of zero. Leading zeros do not count. Leading zeros are zeros preceding a non-zero integer. Okay, there's a number 0.0025. We're going to come back to that number in just a second. The second rule of zeros are captive zeros. Captive zeros always count. Captive zeros are between non-zero integers. All right, let's go back to that first number, 0.0025. Do you see any leading zeros there? Yes, you do. That is that 0, and that 0. Leading zeros do not count. The 2 and the 5 count. So how many significant figures in 0.0025? 2 significant figures. All right, let's look at the next number there, 1.008. The 1 and the 8 count because those are non-zero integers. How about those 2 zeros? Those 2 zeros are captive zeros, and they count because they are in between. They are held captive in between 2 non-zero integers. That is the 1 and the 8. So the 1 and the 8, they count, and the 0 and the 0 count because they are being held captive. All right, bam! So that's 4 significant figures on that one. Let's go to the third rule of zeros here. And the third rule of zeros is trailing zeros. Okay, trailing zeros only count if the number has a decimal in it. And that is they are trailing to the right end of a number. Okay, so we're going to have 4 examples here so that you understand what trailing zeros are. So you have the first number is 700. So in the number 700, the 7 counts because it's a non-zero integer. How about those 0, 0? Do you see a decimal in that number? I do not. And those 2 zeros after, to the right of, that is, the 7, are trailing a non-zero integer, but without a decimal. So those 2 zeros do not count. How many significant figures in the number 700 without a decimal? 1 significant figure. All right, the next number is in exponential or scientific notation. That is 2.00 times 10 to the 8. The times 10 to the 8 are just a bunch of placeholders for the zeros. So the times 10 to the 8 does not matter. Those are placeholders. But you have a 2 point, that's a decimal, 0, 0. So the 2 counts because it's a non-zero integer, and the 2 zeros count because they are trailing a non-zero integer. So there are 3 significant figures in that number. The next number is 600 with the decimal at the end. Now the 6 counts because it's a non-zero integer, and the 2 zeros trailing the 6, they also count because there is a decimal in the number. So that's 3 significant figures. The next number there is 20.0. Okay, the 2 counts because it's a non-zero integer, and the 0 right after, to the right of the 2, that counts because it's trailing a non-zero integer with the decimal in the number. The last 0 on the right-hand side also counts because it's still trailing a non-zero integer. That's the 2, and there's a decimal in the number. So that also has 3 significant figures. Okay? All right. So exact numbers are assumed to be an infinite number of significant figures. So I'm going to give you 2 examples here. One is counting. So if you were to go to the grocery store and say, hey, can you pick out 3 apples? 3 apples is counting. 1, 2, 3. The number 3 has an infinite number of significant figures. It is not a measurement. That's where the difference is. Okay? The second type of example are definitions. So definitions also have an infinite number of significant figures. So I'm going to give you a few definitions here. That is 1 inch equals 2.54 centimeters. The number 1 in 1 inch has an infinite number of significant figures when it equals 2.54 centimeters. The number 2.54 has an infinite number of significant figures when it equals 1 inch. Okay? 1 kilogram equals 1,000 grams. The number 1 in 1 kilogram, it has an infinite number of significant figures, and 1,000 has an infinite number of significant figures when it equals 1 kilogram. So again, you need that unit conversion there. 1 kilogram equals 1,000 grams to have an infinite number of significant figures in both of those. Here's another example of infinite number of significant figures. 1 liter is equal to 1,000 milliliters. The 1 in 1 liter has an infinite number of significant figures, and the 1,000 in the milliliters has an infinite number of significant figures when it equals 1 liter. If I were to measure out 1,000 milliliters, that would have 1 significant figure. All right? That's different than a definition. Okay? That was another Crazy Hat video. I hope you have a great day. Make sure you review that video and give me a thumbs up so I don't get crabby. And subscribe to my video on YouTube. Thank you very much.